on the mass of the Earth is the same for all of us, and the distance that we are from the center of the Earth is the same for all of us. So the gravity is the same for all of us, which is 9.8. How can we find it? G, 6.67 times 10 to the negative 11. Newton times meter square over kilogram square time. What is the mass of the Earth? In average, 5.98 times 10 to the 24 kilogram. Divided by the average radius of the Earth. The average radius of the Earth, so if we take the radius over many spots, and we take the mean radius over millions of points, we will get that the radius of the Earth is approximately 6,380 kilometers, which is about 6.38 times 10 to the 6 meter. So from here, they say that this is the equator, to here will be about approximately 6,380 kilometers. The diameter will be this by 2, from here to here. So if we take this, if we insert it here, 3.38 square times 10 to the 6, when we square will be 10 to the 12. Is that right? Meter square. So if you take the calculator and you multiply this number times this number, and we divide by 6.38 square, now we have 24 minus 11, how much? 13. 13 minus 12, how much? 1, which is 10 to the first, right? So 10, how much have to be this number? So calculate just this number. 6.67 times 5.98 divided by 6.38 square. So if you do that calculation, your calculator, anybody has a calculator? Around 1, so approximately 0.98. Actually will be 0.9789 or whatever. So if you do this 6.67 times 4.98 divided by 6.38, how much? Right? 79? Yes. 79. And how? If this is 0.979, when you multiply by 10, what do you get? 9.79. From that, what we call the 9.8 approximately. So this is the acceleration due to gravity on the Earth, on the surface of the Earth. If we go away from, which is an altitude that is not negligible, we have to get the new acceleration due to gravity. But this is the way that we calculate the gravity on the surface of the Earth theoretically. We found experimentally here in several experiments, right? In the lab. Okay, any question on gravity? How to get the gravity? Now, at any location, this formula. What will happen if I move to twice the radius of the Earth, 2 radii? How much will be the gravity? If I want to go to a second location where it's twice the radius of the Earth, how much will be the new gravity? 1/4 of the gravity on the Earth. 1/4 of the gravity on the Earth, which is 9.8 divided by 4. Everybody got that? So if I go to 2 radii, because the only thing that changes is this again, so you will obtain 1/4 of this value on the Earth, which will be 9.8 divided by 4. Any question? So from here we can do the same thing. If we at 2 different locations, we want to state the relationship, we can say that G2 over G1 will be equal to what? R, if it's inversely, what will be? R2 or R1? R1 squared divided by what? R2 squared. Same relationship. Any question on finding the gravity at two different locations if you have certain values? You take the proportion. Good. We finished with acceleration due to gravity. Now, what will happen if now we have a hypothetical planet? A hypothetical planet, let's say, or a star, let's say a star, has 4 mass of the sun. The new hypothetical star is 4 times more massive than the sun, but has a radius compared to the radius of the sun. Let's say that is 1/2 or 1/3, the radius of the sun. If I ask what will be the gravity on that hypothetical star, what can you do? You have the star is 4 times more massive than the sun, and 1/3 of the radius of the sun. You want to get the gravity on that hypothetical star. To what formula you have to go? To the universal acceleration due to gravity. Universal. G is the same, but the new mass will be 4 times the mass of the sun. So G is the same. This is 4 times the mass of the sun, and will be 3 times 1/3 square the radius of the sun square. Is that correct? I have to square the denominator, which is 1/3 of the radius of the sun square. So how many times is the gravity greater than the gravity on the sun?
4 nines.
So will be, this is 1/9. If you multiply by 9, what will be? 36. So will be 36 the gravity on the sun. What is the meaning of that? If it's 36 times the gravity of the sun, you know that the gravity on the sun is huge. If it's 36 times the gravity of the sun, what is the meaning of that?
Much more densely packed.
And
And
it will pull what? Stronger. Anything that is passing around here will be pulled. If it's anything that is passing around that will be trapped, including anything like light. So if this trap in even light, or light cannot escape because the attractive force is so big, what will happen?
Are you describing a black hole?
That's the definition of a black hole. So this is basically what will happen, that this, because it's 36 times stronger than the gravity of the sun, it will trap anything passing around or won't let escape the light or any particle out of here. So this becomes what you know by the black hole. Very dark matter, which is very energetic and will be into the center of the object, in this case the black hole. So what is the meaning of what is the description? Very simple description of a black hole. It's a very massive star with very small radius. Simply. Sometimes get to the point where it destroyed itself, and it's the famous supernova or whatever we have. Any question on that part of gravity?